Yeah, I mean, I've read the book, very carefully, Superintelligence, and I'm a big fan of it, and I know Nick Bostrom as well, and I think he's a really brilliant thinker. And now, in terms of like alignment of values, I think that the questions that he asks in the context of superintelligence have to do really with assuming that we have a value, and this value, in his case, maybe something to do with our existence, continued existence as a species, or our happiness, and it's really about how we can express this in a way to the machine that doesn't backfire, for instance, or that we can set up a mechanism so that if the machine gets any ideas, we can sort of stop it, right, in its tracks, right? But I think it takes the value as a given, and and that's what the book is about, right? But in my case, I'm saying that as we build AI systems, the values themselves come from us as humans, and they evolve. They've evolved over time, and they will continue to evolve into the future. So, and because I don't believe that they exist in isolation, kind of objectively, that we construct them, they're kind of a reflection of us and our humanity, and we could deviate and we could screw it up and so on, but they emanate from us. And at least if you're a humanist, that's how you would see things, right? Now, then the question is, what are these values today, right? That the machines should maximize in the first place. And I'm not, I haven't figured out a way yet to combine psychological research on people today about, to capture their preferences about superintelligence behavior. Because I think that's a really hard one, and maybe somebody should do that. I haven't thought about it, but I'm saying, with the more benign, more kind of small-scale intelligences, specialized intelligences that we are building now, how I think the engineers could benefit from understanding something about the psychology that generates these values. And for instance, if people seem irrationally unhappy with a death that is caused by a machine compared to many more deaths caused by people, it's important to diagnose why that is the case. Maybe this fear is irrational, and all they're doing is, they're just afraid of the unknown, and the machine is just this unknown thing, and we just need to explain it to them, or just tell them to trust us because we're the engineers and we know it. Or maybe they're afraid of something that we, the engineers, are not thinking about. Or haven't accounted for. I think either way, it's an important thing to study, right? It's important for us to study. And I don't expect the engineers to do this, because that's not what they do, right? But I do hope that behavioral scientists would do this kind of studies, and I hope that the engineers would listen. And some of them are listening, right? And I would say some of them are kind of dismissing, though, and it's because they are thinking in this kind of narrow optimization paradigm, because they're thinking about saving lives or maximizing economic efficiency, and they just say this, they just see these kind of studies as a distraction, or maybe people, they think people don't know what they're talking about, or that they will change their minds, and these are all assumptions, and I think if you knew enough about human behavior and consumer psychology, you would know that these things can be shaped in all sorts of ways. People today are, more people today are afraid of vaccines than they used to before. So things don't always move in one direction either. Messaging is like single study sometimes that turns out to be flawed, matters, and shapes people and people's opinions about life-saving technology, in that case, vaccination. And then it causes, and it sticks, even after the study gets debunked, the belief sticks. So I think if we knew more about human psychology, maybe we would have prepared for these moments sooner, right? So, climate change is another example, right, where public opinion shapes politics, which shapes the kinds of, basically actions, political action that we take towards addressing this problem. So ignore public opinion at your own peril is basically what I'm saying. And then when you look at this kind of dismissal based on this notion that the trolley problem is just this extremely rare edge case, I think that for me that just kind of almost emphasizes the diagnosis that the engineers are looking to optimize for something very specific, and they're taking the example of the case of the trolley problem literally. So they're saying, they look at the data and they say, well, we never face this situation, or we face it so rarely that it's not gonna matter, right? But I think there are two answers to this question, and one of them is that even if it's rare, but people are worried about it, you need to have an answer, because if you want people to accept the technology. But I think the stronger response to this objection is that the trolley problem is a metaphor for any decision that has downstream consequences on the distribution of risk to different groups. So we use this example, myself with Azim Sharif and Jean-François Bonnafont, of what we call the statistical trolley dilemma. So the vehicle is in the lane. A big truck appears on one side in the next lane, and then there is a cycling lane on the left. Where do you position yourself in the lane? It's a very benign decision. It's not a dilemma. There's nothing dramatic going on. It's as benign as decisions go for an autonomous car. Just stay put or move slightly further from the big truck. Now, in one case, two cases, 1,000 cases, maybe 1,000,000 cases, nothing will happen. But over millions of cars, millions of miles traveled, these types of decisions of how many inches you leave are going to impact statistical risk. So it'll either increase the chance that you would hit a cyclist, or it will increase the chance that you would hit the car. That the car that you were in would be involved in a collision with its passengers being harmed. Now, for me, that's like one cyclist versus 5 passengers. That's the trolley problem, right? So basically every decision that we make, and this is just lane keeping, then you can ask you can come up with the same scenario, same kind of dilemma with overtaking. When do I overtake? How much room do I leave with the car coming from the other side? Or even within the lane, how much room do I leave with the car in front of me or the car behind me? Now, so all of these things are going to impact statistical risk. And if we were looking at the distribution of casualties, and we noticed that indeed all the victims are cyclists, then we know there's something wrong going on, right? So I think this is why I think that engineers cannot ignore the trolley problem. And we've written a piece that will appear soon in the proceedings of the IEEE, in which we describe it, and we kind of invite engineers who work on sensors and all these driverless car technologies to take the trolley dilemma more seriously once they understand it metaphorically in this sense.